All right, Algebra 1, here we go. 2-4A Part 2 notes. So let's start off with our bell ringer. So first of all, again, we're looking at these separately. So the numerator, we can't do anything with this. So we're just going to rewrite that numerator, okay? So we're just going to rewrite this 4xy squared. We can't do anything with that. On the denominator, though, we can take out a 2 and an x. So bring a 2x out front, and let's see what are we left with. Well, we take the 2 out. We had two x's, but we took one of them out, so we're still left with an x. Minus 6. If we take a 2 out of 6, 6 divided by 2 gives us 3. And then we started with an x here, but we took that out, so there's no x's left there. And again, it's important that we just kind of identify, like, where is the multiplication happening here. So there's multiplication here and here. So that way we can tell what can we cancel out. So I can cancel out, let's look at the x's first. I can cancel this x with this x here. And then also I can divide the 2 and the 4. So 2 goes into 2 once, and 2 goes into 4 twice. So our final answer on the numerator, I was left with a 2y squared. And on the denominator, I had a 1. And remember, the only time you have to write a 1 is if there's nothing else left. But because I have an x minus 3 left there, I don't need to write the 1 out front. And here we go. There's your final answer. All right, now, for the notes for today, what we're going to do is we're just going to jump right into these examples and just work through them. So, same concept as before. We look at the numerator and denominator separately. So, for the numerator, what can we factor? So we have to remember all of the different types of factoring that we've done. So this one, it's not a dots, right? There's no, it is a difference. There's two terms, but they're not perfect squares. X is not a perfect square, so that means we can only take a GCF out. So greatest common factor here is a 2. I cannot take an x out. The 12 doesn't have an x, so I can't divide an x out. So let's see, what am I left with? X minus 12 divided by 2 is 6. On the denominator, we're going to take and move this down here. On the denominator, this type of factoring is the kind that we typically made our table for. Now, you have already done the assignments where you had to show me the table and show me what number will multiply to give me 6, negative 6 times negative 1, and add to give me a negative, talking and writing at the same time, add to give me a negative 7. So negative 6 times negative 1 is 6. Negative 6 plus 1 is negative 7. So this step right here of actually showing the table is not something that you need to show me anymore. We can just jump right into our answer. Now, if the table helps you, then by all means keep doing your table, because if that is helping you to do the problems correctly, you don't want to stop doing it, right? So if it helps you, keep doing it, but this is not something that I'm looking for anymore. So when I do these other problems, I am not going to show the table anymore. If you want to see the tables and you want to see the work for this, let me know. I will be more than happy to show you the work, but it's not something that we need to see now. These problems have a lot of steps involved in them. This is the work that I'm looking for now, okay? Factor, show me where the multiplying is happening, which is between the 2 and the parenthesis, and then down here is just between the 2 parentheses. So this tells me that, again, in order to cancel something, they have to be exactly the same. Remember that, exactly the same. So x minus 6, see how these both have an x minus 6? We can cancel them out. So what am I left with? Well, up top I'm left with a 2, and on the denominator I'm left with an x minus 1. And that is my final answer. I cannot do anything else with that. Let's move on to the next one. And again, if I'm moving too fast for you, pause the video, come back, re-watch it, slow it down, whatever, watch it at your own pace, okay? So here we go. On the numerator, this is a dots, okay? This is a difference of two squares. Difference, meaning subtraction, two terms, and they're both perfect squares. X is a perfect square. X squared is a perfect square, and 4 is a perfect square. So we can go right into our two sets of parentheses, and we say what times itself gives us x squared? Well, that's an x times an x. Remember, one's a plus, one's a minus. What times itself gives us 4? And that will be a 2 and a 2. Okay? Then we ignore the top and we look at the bottom and we say, okay, what two numbers will multiply to give me 10 and add to give me 3? Multiply to give me negative 10, add to give me 3. These are always going to start with an x. Now, one thing that we can keep in mind is that we want something to cancel, right? So one of these factors on the denominator has to be a 2, either a positive 2 or a negative 2. So if you're thinking about the factors of 10, and one of them has to be a 2, we know that it's going to be a 2 and a 5. All right, so our next question is, well, are they both positive, both negative, one of each, one positive, one negative? And remember when we did this, if the last number is negative, that means we're going to have different signs. So one positive and one negative. And then we look to our middle sign here. Since our middle sign is a positive, that means that the bigger number here, which is the 5, has to match that. So the 5 will be positive and the 2 will be negative. All right, where's the multiplying happening? Well, right here and right there between those two parentheses. Then we ask ourselves, what is exactly the same? Identical. X minus 2 is identical, exactly the same. Not x plus 2 because that's a positive and these were negative. So those two terms are exactly the same. Final answer up top, x plus 2. And on the denominator, x plus 5. Now, the mistake, this is your final answer right here, okay? Final answer, we're done. The mistake that I see happen a lot, and I want you to make sure that you pay attention and try to avoid this mistake as much as possible because I see it happen all the time. People say, well, there's still an x in both of these. Can I just cross the x out and be left with 2 over 5? And the answer is no. And hopefully you remember the reason why we can't do that is because these are being added. These are both over an addition, and we can only cancel over a multiplication. So keep that in mind. All right, next up. Let's look at the top. Oops. Where's that box? There it is. Okay, let's look at the top separately. I need two numbers that will multiply to give me 12 and add to give me 7. Think about it for a second. Two numbers that multiply to give me 12, add to give me 7. What do we have? If you said 3 and 4, you are correct. 3 times 4 is 12. 3 plus 4 is 7. Then we go to our denominator. Okay, what two numbers will multiply to give me negative 18? Okay, multiply to give me negative 18 and add to give me negative 3. And again, think of it this way. If you're stuck on some of these problems, this is one thing that you can do to help you. Which of these numbers, 3 or 4, which of these numbers divides into 18 evenly? 3. So one of these has to be a positive 3. And now it basically just does the problem for you because then you say, okay, well 3 times what gives me negative 18? Or more importantly, what is negative 18 divided by 3? Well, that's a negative 6. Okay? So if you can recognize that something has to cancel, look and see which factor divides into this evenly. Now, in the case like this last one here, let me back up a problem and show you this. When we factored this, positive 2 and negative 2, they both divide into 10. So we didn't know whether it was the positive or the negative 2, but we knew it was a 2. Okay, over here, this next problem is a much, I don't know why it's not switching, there we go, is a much easier one because out of 3 and 4, 4 does not go into 18 evenly. So we know that x plus 4 cannot be on the denominator. But we know that 3 goes into 18 evenly, and it goes in negative 6 times. So 3 times negative 6 gives us negative 18, and 3 plus negative 6 gives us negative 3. Okay, where is the multiplication happening? Because that tells us where we are allowed to cancel. So we can cancel the x plus 3, x plus 3. Final answer, I'm left with x plus 4 over x minus 6. And again, the x's don't cancel, and we cannot divide a 2 out of these and say, well, x plus 2 over x minus 3, because that would be canceling over a positive and a negative, and we can't do that. We can only cancel over the multiplication. This is your final answer right here. Next, again, let's look at our numerator. What do we have up top? What two numbers will multiply to give me 12, and add to give me 1. Multiply to give me negative 12, add to give me 1. So if it's a negative, remember 1 positive and 1 negative. So think about it. What two numbers will multiply to give you negative 12 and add to give you 1? And again, we're left with 4 and 3. Remember, bigger number matches the sign in the middle. So the bigger number here is 4, has to match the middle sign. All right, next, let's look at the denominator. Which of these factors up top, 4 or 3, which of those factors divides into 16 evenly? And that is 4. Hopefully you realize that. So a plus 4 has to be in the denominator. This is a difference of two squares, so what number times itself gives us a squared? That's a times a. What number times itself gives us 16? That's 4 and 4. 1 is positive, 1 is negative. Now we're ready to cancel some stuff out. This is where the multiplication is happening. What can we cancel? A plus 4, excuse me, a plus 4 is exactly the same in the numerator and denominator, so cancel those out. I'm left with a final answer of a minus 3 up top, and on the denominator, a minus 4. And again, remember, what I said before, the parentheses around this are not necessary. You could just have a minus 3 over a minus 4. But usually what happens when I see this written like this is when people want to try and cancel things out, where if you leave the parentheses there, it makes it a little more obvious that those are grouped together, and the only way that can be canceled is if it's exactly the same on the denominator, okay? So I tend to leave the parentheses there, but it's not necessary. You can get rid of them. Okay, next. Now the last two problems here, E and F. These are the toughest ones that we will do. It's still the same process, we just have extra steps. So on the numerator up top, what do we have? Well, we need two numbers that multiply to give us 5. Well, guess what? There's only two numbers that multiply to give you 5, and that's 5 and 1. So two numbers that will multiply to give us 5 and add to give us a negative 4. So that's a negative 5 and a positive 1, right? Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. All right, now I'm going to ignore the numerator and look at the denominator. Well, this one here has a GCF of 2. So let's do one step of taking out the GCF, divide that out. So take it out of the first term, we're just left with x squared. Divide it out of the second one, 8 divided by 2 is 4. Divide it out of the last one, and 6 divided by 2 is 3. Okay, up top, x minus 5, x plus 1. On the denominator, I still have this 2. Now, I'm looking for the factors of 3, factors that multiply to give me 3 and add to give me 4. And again, if you're not sure, we look at the numerator. Does 5 or 1 go into 3 evenly? Well, 1, okay, and that's 1 times 3. So 1 times 3 is 3, 1 plus 3 is 4, so that is our factored form of that denominator. So where's the multiplication happening? Right here, and on the denominator right here, but then also right here as well. What is exactly the same? X plus 1. Get rid of the x plus 1s. What am I left with? Well, up top, I'm left with, let me put my fraction bar here, I'm left with x minus 5. On the denominator, I'm left with 2x plus 3 in parentheses. Final answer right there, and we are finished. One more, the last problem here, and you can already tell by looking at this that this problem is crazy. We have a lot of stuff going on here, so let's just take it one step at a time, okay? One step at a time. Let's start with a GCF. So what can we take out of all of these? The biggest number we can take out is a 4. Can we take a variable out? Yes, all of them have an x, so we can take an x out. Well, what am I left with? I take a 4 and an x out of here. I'm left with an x squared. Plus 12 divided by 4 is 3. I started with x squared. I took one of them out, so I'm left with 1. minus 40 divided by 4 is 10. I started with an x, but I took that one out. So that's it. Now, what I'm going to do here is I'm going to jump down to the next step because I just want to focus on that numerator, okay? So 4x stays out front. Now, what two numbers will multiply to give me negative 10 and add to give me 3? Multiply to give me negative 10, that means one positive and one negative, and add to give me 3. Hopefully you can see it's x plus 5 and x minus 2. All right, so let me switch up the color here, so hopefully this will help you to separate the two. We have a GCF here as 2x, so take the 2x out front. What am I left with? Well, if I take the 2 out and one of these x's out, I'm left with x squared minus 8 divided by 2 is 4. I started with x squared, but I took one of them out, so I'm just left with an x plus 8 divided by 2, again, gives me 4. I started with an x, but I took the x out, so I'm done. Keep going with that. I have to factor now x squared minus 4x plus 4 into my two sets of parentheses. But again, this is going to be very simple for me to do because I'm just going to look at the numerator and say, okay, does 5 go into 4? No, not evenly. Does 2 go into 4? Yes. So x minus 2 has to be one of them. So then we say, what is 4 divided by negative 2? And that's negative 2. So negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. So there is your problem completely factored. Okay, so if you need to pause and rewatch that, do that please, because that's, like I said, that's probably one of the most difficult problems that we're going to do. You won't see a whole lot of those, but they do show up, so I want to make sure you understand how to do that. All right, now let's put our little dots here where all of the multiplication is happening. So right there, 4 times x, x times, and then in parentheses x plus 5, and then the dot right there, those two things being multiplied. There's a dot right there, a dot right there, and a dot right there. That's where all of the multiplication is happening. So this tells us what we are allowed to cancel. First of all, they both have an x. Get rid of it. I can divide a 2 out of both of these. 2 goes into 2 once, and 2 goes into 4 twice. Also, I have an x minus 2. One up top, and there's 2 of them in the denominator. Now, we don't want to cancel this with both of them. We can only cancel this with one of these. Doesn't matter which one, not at all. Take your pick, but only cross out one of them. All right, final answer up top, I'm left with a 2 and an x plus 5. On the denominator, I am left with just the x minus 2, that one copy of x minus 2. Now, here's another thing I want to warn you about. Final answer right here, we're done. What I want to warn you about, this 2 is being multiplied. So some people say, well, this 2 is being multiplied. Can I cancel with this one? This one's being multiplied, but this one is not. This one is being subtracted. So no, we cannot do anything. That's it. Final answer, we're finished. Okay? So again, like I said, this is a confusing, challenging, lots of steps in some of these problems. Rewatch it. Make sure that you understand what's happening here. This is the last section in Chapter 2. We'll practice this for a few days, and then we'll go on to the Chapter 2 test. So make sure you understand how to do this, because you will see a couple problems from this 2-4 section, 2-4A section on your test. So make sure that you understand how to do these problems. If you have any questions, like always, send me an email or a private comment and let me know, and I will answer your question the best I can.